Topic is priority queues. There are two methods of implementing priority queues depending on the situations. So we'll study them. One is a limited set of priorities. I am calling it as limited set of priorities are there. Means already priorities are fixed. The next is element priority. So the element itself will have its own priority. So let us see these two methods one by one. So let us look at first method. See, this method is useful mostly in operating system. Some operating system allows priority based scheduling, like in Java, JVM supports multi-threading, so it's allow priorities upon threads. So you can set the priorities for a thread. And Java supports priorities from 1 to 10. So to 10 different priorities a thread can have. So higher priority threads will execute first. That same thing is implemented using limited set of priorities. Like in Java, 10 priorities are there. So here in my example, I have taken 3 priorities. Now these are the elements. So instead of numbers, I have taken alphabets, and each element is having its own priority. So priorities are numeric values. That's why I have taken elements as alphabets. So this is the priority. Now 1 means highest priority, and 2 is little less than that, and 3 is least priority. You can set it other way also. 3 means highest priority and 1 means lowest priority. Like in Java, 10 is highest priority, 1 is lowest priority. But here in my example, I am saying smaller the number, higher the priority, or larger the number, smaller the priority. This is what I am saying. For implementing priority queue, as there are 3 priorities only in the system, so I have taken 3 queues. So you have to take 3 queues for implementing this one. So now let us look at the working. See, we will insert these elements in this priority queues. So every element is inserted in a priority queue depending on its priority. So A is having priority 1, so it will be inserted in Q1. Then B is having priority 1, so it will be inserted in Q1. C is 2, D is 3, E is 2, F is 1, then G is 2, H is 3, I and J are 2. So the elements I have inserted them based on the priority. If more elements are coming, I will be inserting them. Whenever I have to insert any element, I will check its priority and I will insert it. That's it. Let us look at delete. Whenever you want, you can delete. But whenever you are deleting, you must delete an element from highest priority queue. That is first Q1. So this element must be deleted. You cannot delete any other element. You must delete an element only from Q1. Only from Q1. And that too in FIFO fashion. So strictly FIFO you should follow. Next element I want to delete. So who is the next element? Q1. Q1 is not empty. There is an element. Delete that one. Suppose after J I got one more element whose priority is 1 only. Then it will come here only in Q1. Now again I want to delete. Okay. From Q1 deleted. I want to delete Q1 deleted. Now again delete. Q1 is empty. Then go for second priority. That is this one. Now start deleting the elements from this queue. Suppose after this again I have one element L whose priority 1. It comes here. Then again if I want to delete, I must delete this one. So from this working I can say that deletion should be done always from highest priority queue, and if it is empty, go to the next priority. If that is also empty, then go to the next priority. That's all about priority queues. Now more on this one, that is starvation and all, that are the concepts of operating system. So if you want to study further, you can study it. And you have to implement this one as a student exercise. So write down the program which is having more than 1 queues, and each queue must have priority, and take the elements along with the priorities and insert them. So this is a student exercise. Now next, let us look at second method where every element is having its own priority. Now second method where the element itself is a priority. For example, I have set of elements 6, 8, 3, 10, so on. The element itself is a priority. So the element is numeric, number itself is the priority. So 6 is the priority of that element. And this element, second element, value is 8. So the priority is also 8. So it means there are unlimited priorities. Priority can be anything. And even the elements can have same priority also. Like I can have duplicate elements, 8, one more 8 I have, 8, one more 8 I have. So this is duplicate, same priority. So two elements with same priority. And which one is minimum priority, which one is maximum priority? So for that, I have set the rule here that smaller number, higher priority. If the number is small, then priority is higher. You can change this to other way also, like larger number, higher priority. So if a number is bigger or larger, then it is higher priority. So based on this one, which is of highest priority element? 2. Then second one is 3. The next one is 5. So like this, these are the highest priority elements. So go on. It means if you want the elements in the decreasing order of the priority, means first highest priority, then next highest priority, then you have to arrange the elements in increasing order, sorted order. Next, the question is how to implement this. Now this is not FIFO, this is not FIFO, right? So I have just taken an array. I have to store those elements in an array. So how I should store? So when we want to implement a priority queue using an array for these set of numbers, that is unlimited priorities, there is one known method. We will learn that in some other section. But here I am having two options or two suggestions. So let us see what those suggestions are. First one is, when I am inserting the elements, insert them in the same order as they are coming in. Like suppose insert 6, then 8, then 3 and so on. While deleting, find out the maximum priority element, search for that element and then delete that element. Then second method, insert in increasing order of the priority. So when the elements are coming in, don't insert them as it is. Try to arrange them in increasing order of the priority so that the last element is of highest priority. And when you are deleting, you can simply delete the last element. So the difference in these two methods is, while inserting, we are simply inserting it, but while deleting, we are finding out or searching for an element and deleting it. And here, while inserting, we are trying to properly arrange it. While deleting, we are simply deleting an element. So I will demonstrate how these methods works one by one. So first one I will take. Let us insert and delete few elements. Suppose I want to insert the element 6. Insert it. Next element at the last. Next element at the last. Next element at the last. So every time I am inserting an element at the last. So how much time it is taking for one element? Constant time. Like I want to insert 15. Okay, insert it here. This is the last element, right? The next I want to insert 2. Insert it here. So constant time. Then insert here 9. Right? So this is the recently last inserted element. So the time for insert is constant. Now I want to delete. Delete. So which element I can delete? I cannot delete any element that I like. I have to delete highest priority element only. Then only we say it's priority queue. So which is of highest priority? This 2 is of highest priority. As I said, smaller the number, higher the priority. So 2 is of highest priority. Then how do I know that is of minimum priority? Search for it. Search for it. So search and find out, then delete. So first search and then find out, then delete. Okay, after deleting this one, move 9 here because I have to shift the elements also. The next highest priority, search, which is minimum. This one, smaller number, higher priority. So delete this one. After deleting, also I have to shift the elements. So I have to do two things. Search, which takes order of n time, and shift I have to do for deletion. So that also takes order of n time. So total it is 2n, so we write it as order of n. So insertion takes constant time and deletion takes order of n time. So I was simply copying the elements and while deleting I was searching. Now I will show you second method, that is second suggestion. Now in the second suggestion I will insert those elements. Just watch how I am inserting. 6, okay, 6, perfect. Then 8, see 6 is smaller than 8. Move 6 here and insert 8. Move and insert. Then 3, okay, 3 is smaller than 6, so insert it. 10, so 10 is greater than this one, move 3. 6, 10 is greater than 8 also, move it. Then insert 10 here. So I am inserting an element in the sorted order. Yes, and that is decreasing order. So insert an element in sorted order. So again, 15 I want to insert. So move 3, move 6, move 8, move 10, and then insert 15. So this will shift all the elements. So how much time it is taking for insertion itself? It's order of n, because I have to shift the elements. So searching I don't need, and shifting, so shifting is taking order of n time. I have to shift because I have to insert it in the sorted order. Then how I will delete? Delete. So which is the smallest element right now, right presently? What is the smallest element? 3. So delete 3. So take out 3. That's all. So now the list is still here only. So how much time it is taking? Deletion. Constant time. So this has changed. See, this is taking n time and this is taking 1 time. So that's all. 2 suggestions I have given you. One suggestion was insert them as it is, while deleting use search. Second method, insert them in the sorted order, decreasing order of value, increasing order of priority. So that highest priority element is at the end. So that while deleting, we can simply delete it in constant time. So whichever method you follow, one of the operation is taking order of n time. The other operation is taking just constant time. So that's all. This is not the end of this priority queue. We will learn about the priority queue once again in some other section.